Okay, so we're not going to do this entire thing, like it's front and back. We're just going to do this part and answer the questions. So I don't want you guys to immediately be like, oh, Mrs. Marsh, I'm not doing this. It's too much time. Okay, so we're going to do this thing about Melinda. And she's going to Sam's Club, and she's trying to find a parking spot in the parking lot, which we all know finding parking spots anywhere can be a hot mess, right? Okay, so first let's look over here before we start reading through here. Let's look over at this really awesomely copied graph. You guys, I don't even know. Like, why does this happen with the copier? Like, how is it find, and then not? So I'm going to go ahead and try to sketch in some of the lines just so that I have my grid a little bit easier to see. I don't have words. This is ridiculous. I'm sorry. Okay, so that should be a little bit better. It's not ideal, and I do apologize. Okay, so let's look here. We've got time in seconds. So we have our x-axis and our y-axis. And if you notice, this starts out with 0 to 3. So that's telling you that this needs to go in 3-second increments. So we're going to go ahead and fill these in. It's going to get a little tight here. 27, 30, 48, 51, 54, 56. Hold on a second. No, 57. Okay. So again, I apologize. It got a little tight in there, but it'll do. And then if you look here, these are in 2 increments. The speed of the car is in 2-mile-an-hour increments. So I'm going to go ahead and put -4. Right? And then we've got 4, 6, 8, 10, 12. Okay, so now we're all on the same page, right? You really shouldn't be going that fast in a parking lot, so this makes perfect sense. All right, so now we have everything labeled, so this is going to be easy for us now to plot and connect and make our function, sketch our function. Okay, so it says over here, she started driving in the lot at 10 miles an hour. So starting, meaning that's when she entered the lot, so that's what we're going to put this point here at 10. I'm just going to keep reading this and leave this on the screen because I don't want to make you guys dizzy by going back and forth, but I know you can see the whole thing in front of you. After driving for 6 seconds, she slowed down to 2 miles per hour. Okay, so after driving for 6 seconds, so that means she's at the same speed for 6 seconds, so I went ahead and stopped here at the 6. She slowed down to 2 miles an hour in 3 seconds. So that means that over a 3-second period, she slowed down to 2 miles an hour. So our next thing is going to be at 9, because 6 seconds to 9 seconds is 3 seconds, and now she's down at 2 miles per hour. Okay. She continued at this speed for 3 seconds. Cool. So for the next 3 seconds, she stayed at 2 miles an hour. She's kind of lurking through the parking lot, right? Barely moving. As she turned down an aisle of the lot, she spent the next 3 seconds increasing her speed back up to 12 miles an hour. Wow. So she's going to go from here and she's going to go all the way up to 12 miles an hour over a 3-second period. So I'm going to connect those 2 dots here. Maybe she saw a spot. Who knows why she's going so fast in the parking lot? Anyway, sorry. Okay, as she approached an empty space at the end of the aisle, a large passenger van entered the aisle from the opposite side, blocking her path. She took 3 seconds to come to a complete stop. Hold on a second. She spent the next 3 seconds. Oh, stayed at this speed for 6 more seconds. Okay, so really quick, back up here where she was like cruising through the lot, she stayed at that speed for another 6 seconds. So let's go ahead and add that in. So now we're at over to 21 up to 12. Okay. She located a spot further down the aisle. As she approached an empty space at the end of the aisle, a large passenger van entered the aisle from the opposite side, blocking her path. She took 3 seconds to come to a complete stop in order to avoid hitting the van. So she basically slammed on her brakes. You guys like my brake sound? I've been practicing. Okay, so now we're down here. Melinda spent the next 3 seconds stopped as she switched gears to reverse her car. So now we've got a point here where she's just going from drive to reverse. Fortunately, no other drivers were behind her, and she started traveling back up the aisle. It took 3 seconds for Melinda to reach a speed of 4 miles per hour as she backed up for the next 6 seconds. Woo! Okay, so this is going to sound weird because now she's backing up, so we're going to count that as negative miles per hour. Does that sound weird? It does sound weird, but we're going to pretend that that's what's happening. So she switched into reverse. There were no other cars. She tried back. It took her 3 seconds for Melinda to reach a speed of 4 miles per hour as she backed up. So we're going to go all the way down here to 4 miles per hour, and we're just pretending that if you go in reverse, it's negative speed. Just pretend with me, guys. Okay. And she backed up for the next 6 seconds. So we're going to go for the next 6 seconds. She's still at that 4 miles per hour, and she's, in reverse. So we're counting it as negative. I'm going to go ahead and tell you guys, I promise, just like with the other thing, it will not be this elusive. You won't have to guess that I want for you to be in the negatives for reversing a car. Okay. Woo! She slowed down as she backed into an empty area at the back of the lot, and she came to a complete stop. This took 3 seconds. So now she's at a complete stop. She's not moving. She's hanging out. She waited another 3 seconds as the van passed by. I'm sure she was giving that driver a really nice look. She then proceeded back down the aisle again at 14 miles an hour. Woo! It took 3 seconds for her to increase her speed. She mad. Okay, so I'm going to go all the way up to here where 14 would be. Make this a super narrow connection. Okay. After 6 seconds of driving, trying to find the new parking spot, so she's cruising at 14 miles an hour again. I guess I should have put the 14 up here on my y-axis. Melinda slowed down for 3 seconds as she pulled into a new parking space and came to a complete stop. Whew, this adventure is over. So now I'm going to go all the way back down here. My goodness, poor Melinda. What a traumatic day at the Sam's Club. After that, do you even want to go in and try to buy anything? That's crazy. Okay, so now we have our beautiful sketched function. Okay, so now we're going to answer questions 1 through 13. It's going to go super fast. All right, so I'm back over here on question 1. It says, what quantity described above is represented by the independent variable? Well, this is time, right? Let's remind ourselves that that's the x-axis title. What is the dependent variable? Well, this is speed of the car, and that is our y-axis title. Some questionable speeds, if you ask me. Okay, now number 4 says, which ordered pairs are the x-intercept? Okay, so we have several, right? We have 24, 0. We have 27, 0. We have 39, 0. Notice that the y values are always 0. We have 42, 0. And we have 54, 0. And what do they represent? They represent the car not moving. Right? So 0 miles per hour. What ordered pair is the y-intercept? That's going to be 0, 10. And what does this represent? This is her speed entering the lot. So where is the domain in this relation increasing? Well, we could say it's increasing between 12 and 15. And it's increasing between 42 and 45. Oh, I missed one. 36 and 39, right? Because she was going in reverse. and then between 42 and 45. So when is the domain decreasing? Well, it decreases from 6 to 9. It also decreases from 12 to 0. Excuse me, not 12 to 0, 21 to 24. For some reason I started thinking about the range. It also decreases from 27 to 30. And then increase, and then again from 51 to 54. Okay, for what elements in the domain is the relation positive? So what are my, oops, I'm sorry guys. I know you could probably figure out what I was doing. Okay, so what are my positive x values, right? So basically between 0 and 24, right, because those are above, and then between 42 and 54. Right, because I'm looking at all of these possible things that are above the x-axis. Those are my positive relation. That's when the relation is positive. Okay, let me zoom this in. And like always, guys, please pause as needed. All right, so let's go back here. So for what elements is it negative? So if you're looking at that graph, probably you would see really it's only negative between 27 and 39. Right? Because if I turn this over, we just have this weird chunk of negativeness. Remember we said that's when she was driving backwards. What is the absolute maximum? What does this represent? So if you go back and look at the graph, the absolute maximum is 14. And it happens to be, what is that, 4214 is my ordered pair, and that is her speed, her fastest speed. At 42 seconds. Okay. What's the absolute minimum? What does this represent? So this is where it gets a little wonky. The absolute minimum is going to be, let's say, over 30 down 4. And if you had chosen the other ordered pair, that's fine too. I'm not going to, count that wrong. And this is her slowest speed, because again, we're counting reverse as being a negative speed. Okay, at 30 seconds. Right, that's when she was trying to avoid that van. Identify a relative maximum, state the interval at which it exists. Identify a relative minimum. So remember, relative maximums and relative minimums are not the highest point, but they still are considered a peak. So I could have this as a relative maximum because it's a peak, but it's not the highest. Or I could have 12 as a relative maximum, okay? And that would be between 15 and 21, right? So we have lots of choices here. So I'm going to choose 12 for my relative maximum, and that's between 15 and 21, right? And then my relative minimum, so I need a lower point but not the lowest. I'm going to choose 2, okay? And that's going to be between 9 and 12, right? That's going to be my option. Okay, So that was the bell, which means students are coming, which is perfect time for me to end this video. So bring this back with you, at least completed this much tomorrow, and we will continue. We might not even do this problem, but we're definitely going to talk about 15 and 16 tomorrow in class. All right, thank you guys. See you tomorrow.